Now, let's say we have this 3 by 3 matrix P here, and we are asked to find P square minus 12P plus 44I. So I here is the identity matrix with 3 rows and 3 columns. Okay, then the next part we will show that P multiplied by P square minus 12P plus 44I is equals to 48I. And from there we will deduce the inverse of matrix P. So first we'll calculate what is P square. We'll simplify it first. Right, so we will first start from the first row, okay, the first row and the first column. So that will be 2 times 2 plus 2 times 0 plus 4 times negative 2. So that's negative 4, right? And then we'll move on to the next column, okay, which is 2, 4, and 2. So from there, this is 2 times 2 plus 2 times 4 plus 4 times 2. Okay, so that's 20. And then moving on to the next column. So that's 4, 4, and 6. So here we have 2 times 4 plus 2 times 4 plus 4 times 6. Okay, so that's 40. Right, now we move on to the next row. And we start back from the first column again. So second row 0, 4, 4. And first column 2, 0, and negative 2. Right, and here this is 0 times 2 plus 4 times 0 plus 4 times negative 2. So that's negative 8. Okay, and moving on to the next column, right? So that's 0 times 2 plus 4 times 4 plus 4 times 2. Okay, so we get 24. Okay, and let's move to the third column. Okay, and let's calculate that. So that's 0 times 4 plus 4 times 4 plus 4 times 6. So that's 40. And then move to the last row. So that's negative 2, 2, 6. And 2, 0, and negative 2. Okay, so let's calculate that. So that will be negative 2 times 2 plus 2 times 0 plus 6 times negative 2. So that's negative 16. Okay, and the next column. Right, so this is negative 2 times 2 plus 2 times 4 plus 6 times 2. Okay, so that's 16. And then for the final column. Okay, so that's negative 2 times 4 plus 2 times 4 plus 6 times 6. So that's 36. Okay, so now that we have P squared, we can now substitute it into this expression here, and then we'll simplify it. Okay, so we'll have P squared. So we have P squared minus 12P plus 44I. Okay, so of course P squared is something that we have obtained here. So I'll just substitute this in. Okay, 24 and 16. This is 40, 40, and 36. Okay, and then for 12, so this is minus 12, and then multiply by P. Of course, you can directly multiply it, the 12 scalar, into the matrix, but I'll just do it step by step. So that's 2, 0, negative 2, 2, 4, and 2, 4, 4, and 6. Okay, and then we will add in 44i. So 44i and I here, the identity matrix is 1, 0, 0. 0, 1, 0, and 0, 0, 1. Okay, that's the identity matrix. Now I will simplify the two matrices here. So of course P squared is still the same. Okay, I mean no change there. So I'll just copy it down here. So this negative 4, negative 8, negative 16. Okay, and 20, 24, 16, 40, 40, and 36. Okay, and then for 12P here. So this will be 12 times 2 is, this is 24, negative 24, 24, 48, 24. Then this is 48, 48, and 72. And then this here will be 44, 0, 0, 0, 44, 0, 0, 0, and 44. Right, now let's simplify these three matrices here. So for the first part, we have negative 4. Okay, negative 4 minus 24, that's negative 28, okay, plus 44, so that will be equals to 16. Okay, and then can calculate all these numbers here, just if you want to verify. Okay, just be careful when doing the workings here. So the next first row for the second column, so that's 20 minus 24. Okay, so plus 0, so that's negative 4 there. Okay, and then the next column, so 40 plus minus 48 plus 0, that's negative 8. Okay, and then we move on to the second row. So we have negative 8. Okay, negative 8 minus 0 plus 0, so that's negative 8. Okay, and then next one is 24 minus 48 plus 44, so that's 20. Okay, and then the third one would be 40. 40 minus 48 plus 0, that's negative 8. Okay, and then negative 16 for the third row. Okay, so this will be negative 16 minus negative 24 plus 0, so that's 8. Okay, and then we have 16. Okay, 16 minus 24 plus 0, that's negative 8. So finally we have 36 minus 72 plus 44. Okay, so that's 8. Right, so this is p squared minus 12p plus 44i. So the next part, we need to multiply p to the p squared minus 12p plus 44i and show that it is equals to 48i. Okay, so this is what we're going to do next. So we're going to take p times p squared minus 12p plus 44i. Okay, so p, okay, from the part earlier, so this is 2, 0, negative 2, and you have 2, 4, 2, 4, 4, 6. Okay, and then for p squared minus 12p plus 44i, so we'll just copy the answer here from the previous working. Okay, and again, we need to multiply this these two matrices. Okay, so let's start with the first row. Okay, again, we start with the first row, and then we go by the first column. Okay, so that will be equals to 2 times 16 plus 2 times negative 8 plus 4 times 8. So that is 48. Okay, and then the next column here will be, then we move on to the next column. Okay, negative 4, 20, and negative 8. So here, this would be 2 times negative 4 plus 2 times 20 plus 4 times negative 8. So that's 0. Okay, and we move on to the third column. So what do we have here? So we have 2 times negative 8 plus 2 times negative 8 plus 4 times 8. So that's 0. Okay, and now we move on to the second row. Okay, and 16, negative 8, and 8. Okay, so here we have 0 times 16 plus 4 times negative 8 plus 4 times 8. So that's 0. Okay, and move on to the second column. So here this would be 0 times negative 4 plus 4 times 20 plus 4 times negative 8. That's 48. And then for the third column, okay, third column here. Okay, so this will be 0 times negative 8 plus 4 times negative 8 plus 4 times 8. That is 0. And we move on to the last row, and we multiply it to the first column for the second matrix. So this will be negative 2 times 16 plus 2 times negative 8 plus 6 times 8. Okay, so that is 0. Multiply, then move on to the second column. So this is negative 2. So that's negative 2 times negative 4 plus 2 times 20 plus 6 times negative 8. So that is 0. And then finally, the last column here. Okay, we have negative 2 times negative 8 plus 2 times negative 8 plus 6 times 8. We get 48. And there we go. Finally, this is this final matrix here will be equals to 48 times 1, 0, 0, 0, 1, 0, 0, 0, 1. Okay, which is 48i. Okay, so therefore we have shown that. We have showed that p times p squared minus 12p plus 44i is equals to 48i. Okay, so this is shown here. Right, and the last part of the question is to deduce the inverse of matrix P using this equation. Okay, so what we need to do now is we just have to recognize that if I multiply P by another matrix and I get 48i, okay, and we know that if you multiply a matrix to its inverse, we should get a single unit I, but here we have 48i. So what we need to do is I need to move this 48, I need to the left hand side, so I divide both sides by 48. So in other words, I can show that P multiplied by 1 over 48 times P squared minus 12P plus 44i is equals to the identity matrix. In other words, here the 1 over 48 times p squared minus 12p plus 44i can be deduced as the inverse of matrix P. So we can say that the inverse of matrix P is 1 over 48, okay, multiplied by p squared minus 12p plus 44i. Okay, and finally we just substitute the matrix in. So earlier we obtained this as 16, negative 8, 8, negative 4, 20, and negative 8, negative 8, negative 8, and 8. Okay, don't leave your answer in this way. You have to multiply the scalar into the matrix. So express your answer as a single matrix. So 16 over 48 here will be 1 over 3. And then negative 8 over 48, that's negative 1 over 6. 8 over 48 will be 1 over 6. Right, so I probably need a bigger space here. Okay, and for the next column, so negative 4 over 48, that's negative 1 over 12. 20 over 48, so we simplify with 4, so that's 5 over 12. And then this will be negative 1 over 6, negative 1 over 6, negative 1 over 6, and 1 over 6. Okay, so that would be the inverse of matrix P. Okay, so this is your final answer when you show it as a single matrix.